In this example, we want to calculate the heat transfer from a 8-inch diameter potato that's initially at 20 degrees C. We are cooling the potato by putting it in a refrigerator that has air blowing on it at 5 degrees C. The speed of the air is 1 meter per second. We also have a table of air velocity versus heat transfer coefficient. So from this table, we can get the appropriate heat transfer coefficient to apply. So in this case, we look at our numbers we have. So here, air is coming in at 1 meters per second. So if we come across, our heat transfer coefficient is 19.1 watts meter squared Kelvin. So first thing we need to do is we need to calculate the thermal conductivity K of the potato. We're going to using the average temperature. So 20 degrees C plus 5 divided by 2 is 12.5. So if we look in table A15, that has a table of properties of air at 1 atmospheric pressure, which is what we are. If we go down to 12.5, we don't have a 12.5. We have a 10 degrees C and a 15 degrees C. So our value for thermal conductivity is somewhere between 0.02439 and 0.02476. So the best way to do that is interpolate between those two values. You can use your calculator to do this. I use the point slope formula. Basically, you can calculate the slope, subtract this K value from this K value, and divide it by this temperature over this temperature. That gives you the slope of the straight line curve. Then plug in the other values for the point slope. You can calculate K to be 0.02458. It's always a good check here to make sure that this value is between these two values. This is a double check, and in this case it is. And again, you could use your calculator to calculate this, but it's hard to show that on the screen. So to find the initial heat transfer coefficient, we use Newton's law of cooling, H times A sub S, T sub S minus T infinity. H we found from the previous table. Our A sub S value is given in the problem. 20 minus 5, so we calculate this as 5.8 watts. So that's the initial heat transfer rate, 5.8 watts. To find the temperature gradient, we need to apply this formula here and solve for the partial T with respect to R at R equals R, which is the radius of the potato. So here, if we solve for this value, we rearrange our equation, we get this equation here. So we can plug in our H value, the temperature difference divided by K. So we get minus 11,666 degrees C per meter. That's our final answer.